Hello, good morning students. Now we are back with the third chapter of our chemistry, that is atoms and molecules. Until now we have completed our two chapters, that is matter in our surroundings and is matter around us pure. Now we are on the discussion of our third chapter of chemistry, that is atoms and molecules. So firstly we will discuss what actually the atoms are. Suppose I am saying you matter. Matter is something that has mass and occupies some space. It means every matter in a universe is made up of certain type of atoms. Suppose I am considering this chalk particle. This chalk is made up of very tiny particles, and the very small tiny particles which do not divide further are called atoms. So everything in the universe is basically made up of several kind of atom. So what actually the discovery of the atom has been discovered further, but before this some Indian philosopher say something about different type of atoms. So firstly we have one Indian philosopher, his name is Maharshi Kannad. Maharshi Kannad says about the atom that it is a smallest particle of the matter whose further division is not possible, and he defined that term atom in Hindi. It is called Parmanu. So ancient Indian philosopher Maharshi Kannad says about there is an indivisible particle of a matter, and we will call that particle as Parmanu. These particles will be called as Parmanu, and actually these Parmanus are atoms. So what actually the atom is? First point, he concluded that it is an indivisible particle of matter. Second point, we have concluded everything in our nature is made up of some type of atoms. So basically he concluded two things about atom, that atom is a something and atom is a that state of matter whose further division will not be possible. But after some time later discoveries were done by next scientist, and the next scientist is Dalton. What actually Dalton say? Dalton describe these terms as atom, as Maharshi Kannad said it about Parmanu. Dalton said that these indivisible particles are called atom. It means atom is a smallest particle of any matter whose further divisions cannot be possible. Next thing we have to learn about the atom is it cannot be seen with naked eye. We can't see the particles of an atom with our naked eye. We have to need a high resolving microscope for observing these type of particles of the atom. Next property come about the atom is that in atom these atoms will not exist in their free state because they are very reactive. Next property here is atoms do not exist in free state. So these conclusions are basically made by Dalton about the atom. That first point is, it is an indivisible particle of matter. Second, everything in our surrounding is made up of some small particles. These are called atoms. It cannot be seen with a naked eye, and atoms cannot exist in their free state. It cannot exist in the free state. It means they are always present in some combined form by reacting with other type of element. Now, to identify the elements, John Dalton gave certain type of symbols. But firstly, we have to identify the size of the atom. So what actually the size of the atom is? Now we are going to discuss about the size of the atom. So our next topic is size of atom. The atomic size will always be defined in terms of atomic radius. Size of atom is always defined in terms of atomic radius. The units for calculating the atomic radius will be in basically nanometers. Unit for calculating the atomic size will be in nanometer. Here we have a relation, 1 nanometer is equal to 10 raised to the power minus 9 meter. 1 nanometer is equal to 10 raised to the power minus 9 meter. This will be the formula for changing the nanometer into meter. Now, atomic radius is a factor for defining the size of the atom, which is generally very small. So, in this sequence, we have an example of hydrogen, which is the smallest element exist in nature, and it have a radius of approximately 0.037 nanometer. So, third point of discussion is atom exists in nature. Hydrogen, it is having a smallest size, and the radius for hydrogen atom is 0.037 nanometer, which is too small. So, it is all about the size of the atom. As I have already told you, the atom always exists in some combined form, they never exist in the free state. Now, Dalton gives some symbols for identifying the element. Now, I am going to tell you what actually the symbols are. So, our next topic of discussion is the symbols of element. We have symbol of elements. So, what actually the symbols of elements are? Symbols of elements are the shorthand notation for identifying any element. Suppose we have to identify the hydrogen, so we have to describe some symbol for identifying the hydrogen. So, what are the symbols? These are the shorthand notations. Symbols are the shorthand notations for identifying elements. So, symbols are the shorthand notations for identifying elements. So, Dalton gave some specific format or signs for writing the symbols. Here I am showing you what are the shorthand notations for writing the symbols. We have symbols of elements. These symbols are actually given by Dalton, because Dalton studied more about the atom. So what actually we have? We have name of element here. In the next line we have symbol for representing them. So if I write first symbol, suppose I am having hydrogen. So for defining hydrogen, Dalton gave the symbol. We will use this symbol for defining hydrogen. Second example we have about oxygen. Suppose we have to define oxygen, we will use this simple symbol, that is circle. In the third sequence we have carbon. Suppose we have to express the carbon, we will write the symbol as in a circle, we will write C. Fourth, suppose we have to express nitrogen. If we want to express the nitrogen, we will use the symbol like this. Fifth example we have, suppose we have to express zinc, we will have to write the symbol Zn over here. So these are the basic symbols given by Dalton to identify the elements. Now we are discussing how compounds are formed after discussing these elements. We have compounds from symbols. Suppose I have to express first formula for water. We know the molecular formula for water will be H2O. Now in terms of Dalton symbol, I have to express H2O. So how can I write H2O? We have symbols for H is dot and oxygen is O. For the formula of water can be written as this dot. So this is the concept for writing H2O. Suppose I have to write the second formula. Carbon dioxide. The basic formula for carbon dioxide gas is CO2. So for writing the C, we have this formula, and for oxygen, we have this. So we can write the CO2 in this manner. Firstly, we will write the C in the center, and we have. So this is the formula for writing H2O, and this is the formula for writing CO2. But this symbolic notification is not easy to understand and cannot be studied for further processes. So this idea of Dalton has been failed for writing the symbols in this manner because it is not an appropriate idea to identify any element. So after this, the next scientist came whose name is J.J. Berzelius, and he gave that the symbol of an element will be written from the first letter of the alphabet. So after this, after Dalton's atomic structure formulas, we have the next scientist, that is J.J. Berzelius. He gave the symbols of the different elements according to their initial element or according to their Latin name. Now symbol of elements. Next category is given by J.J. Berzelius. he actually gives the modern symbols to recognize any element. He gives modern symbol representation. In the modern symbol representation, what he said that always if we write any element, the name of the element will be the first letter of the symbol, whether it is its original name, whether it is its Latin name. So, what J.J. Bergelius had told, J.J. Bergelius gave the modern system of representation of the symbols, and he actually told that symbol will be the first letter of the element, first letter of element name, and he also told that it must be written in the capital letters. It must be written in capital letter. If we have the two symbols for writing an element, the first will be written in the capital letter and other will be written in a small letter. So, third point for the J.J. Bergelius symbol theory will be first letter will be capital and second letter will be small. Suppose I am considering an example of oxygen. So, according to J.J. Bergelius, if we have to write the oxygen, we will write the symbol is O. If I am writing about carbon, the symbol will be C. If I am writing about any third element, that is, suppose I am writing about iron, the word iron is taken from the Latin language, that is ferrum, so its symbol will be Fe. So, we will write capital F and small e. So, according to the J.J. Bergelius, these will be the representation of symbols of the elements. Now, in our next lecture, we will discuss about many more elements. So, this lecture is over for today. Thank you so much and have a nice day.